15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thank you for joining us. This is the Space Nuts podcast, all about astronomy and space science, what's happening in the wider universe or in your backyard, perhaps. My name's Andrew Dunkley, your host, and joining me as always is Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. How are you doing?
I am very well, sir. How are you?
Yeah, equally well, probably.
That's good. That's good.
Slightly older, but equally well.
Only slightly.
Yeah.
In universal terms, it's very slight.
It is, that's right, yeah.
Super slight. Now, before we get on to today's topics, I've got something to show you, which won't help people listening via the podcast or the radio network, but if you're a YouTuber, you'll see it. I am in uniform. Look. Check it out.
Oh, wow. Ah, fantastic. The Space Nuts shirt.
Yes, I've got a Space Nuts shirt with an embroidered logo, and apparently you're getting one soon too, Fred.
I believe I am, yes. Yeah. I believe there might be one coming from me.
It's only taken us 5 years to make enough money to pay for a logo. Yeah.
And to pay for one each for us.
One each as well, yes, exactly right. Now, coming up on this particular edition of Space Nuts, we're going to look at an incident involving the International Space Station. They've had a little bingle. Plus, the search for the origin of the asteroid that polished off the dinosaurs, and not in a good way. No polish involved, in fact. It was a huge mess. And we're going to answer some audience questions. One about, it's sort of a multi-pronged question about pulsars and quasars. What's the difference between them? How does matter escape a black hole? And, a few other things involving black holes, pulsars and quasars, and we'll get onto that. And we've got a question from the United States about explaining the heliopause and the journeys of Voyager 1 and Voyager 2. And it's a great question because I don't think we've ever been directly asked to explain the heliopause before. I won't be doing that, but Fred will be. So we're going to cover all of that today on the Space Nuts podcast. But first, Fred, let's head out to the International Space Station, and there's been a little bit of a hiccup.
Yeah, there has, which has sort of set back a program that's of great interest to all of us, which is getting the Starliner up there to do a test flight, which is Boeing's answer to the Crew Dragon module that SpaceX runs up and down these days to the International Space Station. So what happened was a new module for the space station, and it's a Russian one, so it goes on the Russian half of the space station, whose name is, I think I'm right in saying it's Nauka. It is, I'm not sure whether I'm pronouncing that correctly, but it looks like Nauka to me. And what happened was that module, essentially, it's a big piece of kit. This thing's 13 meters long and weighs 20 tons. So it's not just a tin can that's being attached to it. It's a tin can, but a very big one. And what it will do is give the Russian segment of the space station much more space. It'll open it up, and most importantly of all, Andrew, it carries an extra toilet as well. So that's a really you can't have too many of those things.
You cannot have too many bathrooms on a space station, I'm sure.
Yes, exactly. So what happened was the Nauka module headed up there on, I'm not sure what the launch vehicle was, but it made rendezvous with the space station, did all its stuff. This is a few days ago now. But once it had docked with the International Space Station, this was about 3 hours after everything had gone. The flight itself took 8 days to get from the surface of the Earth. Nauka docked with the space station. Everybody had a cup of tea or whatever you do when something like that is just finished. But then it started firing its rockets without a command to say, fire your rockets. These are thrusters that are on that Nauka. and they began firing at I don't know whether it was full power, or because I don't even know whether these are throttleable. They might be on or off. Anyway, it fired for a matter of minutes before a command was given to kill everything and cut the motors, and that then resulted in a recovery operation, which happened very quickly. What it did, Andrew, was not to shove the space station off its orbit. That would probably have required a bit more oomph to do that. Yep. But what it did do was change the attitude of the space station. In other words, it tilted it over with an error. It moved it by 45 degrees. And you can easily imagine that, because this module, its thrusters, when they fired, would not fire in the line of the center of mass of the space station, which is what you'd need if it wasn't going to change the attitude. Any other thrust is going to tilt it one way or another. 45 degrees, which is quite significant. Now, of course, in space, it doesn't matter which way is up, because you're weightless. However, the space station has to be kept at the right orientation. It's all about the solar panels and the orientation with respect to Earth and things of that sort. So there was another operation with thrusters on board another Russian segment, which is Zvezda, and a Progress freighter that's also docked. They basically, the rocket motors on those segments were used to bring the space station back to its proper orientation. And the whole thing was over in less than an hour. In fact, it was really quite very, very neatly done. NASA's tweet about it was, space station crew members are safe and will scrub their schedules for today in order to focus on recovery efforts following the unexpected loss of attitude caused by the Russian Nauka module's thrusters firing. Station is back in attitude control and is in good shape. So all is well, but it apparently, in a later report I read, it seems to have traced the erroneous firing, or the errant firing of these thrusters to a software issue, which is exactly the kind of thing that you might expect.
I was betting on somebody flicking a cigarette out the window.
Well, you never know. Yes. Meanwhile, back in the real world, there's quite a long story with Nauka, because it should have launched 14 years ago.
Wow.
But there were all kinds of slips in schedule, budget difficulties, technical problems, the whole thing. And apparently, even after its launch, I remember I said it took 8 days to get up to the space station. Actually, it doesn't take that long to get up there, but then you've got to do all the catching up with the space station and orientation and everything. Yeah. Apparently, on its way up, it had propulsion issues, which, as the BBC said, required workarounds from controllers in Moscow. But it did arrive on the planned schedule.
Sounds like it was built by a Russian car company.
Well, I won't comment on that, but you could be right. What it does do, it raises the volume of habitability on the space station by 70 cubic meters. So this is quite a significant addition. And as I mentioned, there's an additional restroom there for crew use. What else was on board was an 11-meter long robotic arm, which is called ERA, which I suspect is the European robotic arm, because it comes from the European Space Agency. And that's something that is a device that's built for external operation around the Russian segment of the space station, which has obviously got fittings on the outside that this thing will link onto. It's got, it's interesting, the structure of it. It just looks like a large pair of compasses, if you remember what
Oh,
they
yes.
look like.
I remember those things.
Yeah, and apparently, the ends of the two arms grab onto fixtures on the external part of the Russian modules, and it basically grabs one, pulls itself along, grabs the other, pulls itself along. So it walks along the outside of the module, moving hand over hand, as the BBC report put it. Quite a nice way of putting it.
Oh, impressive.
Yeah, it's great. The one thing that has happened is, as I mentioned, it's pushed back an uncrewed test flight that was scheduled for last Friday of the Boeing Starliner capsule, which is an equivalent of the SpaceX Crew Dragon, and that was the earliest date that they could do it, I think, was probably today or maybe yesterday, and I haven't heard whether that launch has taken place, so I suspect it's still on hold.
So I wanted to ask you about the Starliner. This is essentially going to be a transport vehicle.
Yes, it's able to carry crew. So in the same way that the Dragon capsule can carry cargo or crew, there are different versions. This will be the same. I have to say I don't know that much about it. I think Starliner is specifically just backtracking there to 2011 when the new version of NASA was wheeled out, where the commercial sector was going to be essentially co-opted to carry out transport of astronauts up and down to the space station using commercial vehicles rather than NASA sponsored ones, even though NASA's funded it. The two companies that sort of won out, actually there were three, because what was then Orbital Dynamics also had a module. That's changed hands now. I think it's part of Northrop Grumman. I might be wrong there. These things need a bit of attention to keep up with them. But the two ones that were in the lead, I mean, SpaceX kind of won the race, as it were, with their Crew Dragon, which has now made at least 2 crewed flights to the space station, maybe more. Boeing was the other winner in the contract race, but also is about to test out their Starliner. It's a nice name, isn't it, for a spacecraft? Yeah.
I like it. Yeah, just by the by, my son, not long after he moved to Sydney, worked for a company that had a contract with Boeing Aerospace. So he did actually work for Boeing on some of their aerospace contracts some years ago. Yeah, I don't think it was, I think it was mainly ordering parts and bits and pieces and things like that. But he might have had something to do with the Starliner and not even know it.
Who knows? Yes, he might not.
Yeah, fascinating work, and I think when you were trying to think of a way to describe the re-gearing of NASA so that all the transport sort of went to the private sector. Yeah, they call that outsourcing.
Ah, yes, I've heard of that.
Outsourcing. Yeah. So everything is well. That's good news with the ISS. Of course, the journalist in me has just come up with a list of what-if questions. What if they couldn't shut it down? What would have happened then?
Well, it would have eventually run out of fuel, and it could even have sent the space station into a spin. And doing that would have meant some very quick thinking on behalf of the controllers who sit watching these things at all times, both in Moscow and down in Houston. The thing they'd have had to do was work out which thrusters elsewhere on the space station you need to fire to oppose the torque, the rotation that's being provided by the errant one.
It's pretty scary, and I imagine initially they would have been absolutely stunned by what was happening. But from what I've read, the way they reacted and dealt with it was extremely brilliant and clever, and they would have all sorts of safety protocols, and they would do all sorts of drills regularly to cover all possible contingencies. And obviously they'll do an investigation, they'll learn from this, and they'll be more ready next time, if there is a next time, and you hope not. But I would imagine the training that they go through and the protocols that they would have, and if all else fails, their escape plans would be something that would be very well drilled into the astronauts and cosmonauts. So It's all credit to them. They solved this problem brilliantly, from what I've read. Fantastic
It
job.
looks like it, yeah. I mean, it's sort of akin, the way pilots are trained. The first thing you learn is how do you get out of a spin, or how do you correct a roll
Stall.
or something like that. Stall, yeah. So, and that's drilled into them from the word go. And I guess the same kind of thing probably happens on the space station. Next time I'm talking to an astronaut, I'll ask him. Or her.
Yes,
sorry,
indeed.
beg your pardon. In fact, I was talking to one last week, but he didn't listen to what I said because he was on a webinar.
Fair enough. Anyway, it's all good news for the ISS. A little bit of a dust up, but back to normal now.
Yep.
This is the Space Nuts podcast. Andrew Dunkley here with Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Yes, thanks for listening. And Andrew Dunkley here with Professor Fred Watson, of course, and a big hello to all our social media followers. If you haven't started following us on social media yet, I suggest you do. If you've got a Facebook account, you can join the Space Nuts Facebook page. But there's also a Space Nuts podcast group on Facebook, which is it's geared to basically give you an interface between fellow listeners. So you can all get together and chat and swap ideas and ask questions of each other. It can be anything from, showing off your telescope right through to talking about something extraordinary that's been discovered in the universe and putting theories and discussions behind it. So it's a great little group and a lot of fun. So look for it on Facebook. Just do a search for Space Nuts or Space Nuts Podcast Group. Join both. Why the heck not? I mean, cost you nothing. Okay, Fred, let's move on. And we've talked about the asteroid that killed off the dinosaurs, which plummeted into what is now the Gulf of Mexico, or part thereof, around 66 million years ago. One of the great mysteries of this is we don't really know where it came from, and they've been trying to figure that one out. Have they come up with a theory or indeed an answer?
It could be an answer. That's right. It's this is really interesting work in terms of our understanding of the asteroid belt in particular, but the frequency with which the Earth might be zapped by impactors. So what's happened is that do you remember Myrtle, Andrew?
Yes,
Myrtle was
yes.
the drilling rig in the Gulf of Mexico that drilled down to get samples of the material that this asteroid was made of. And I assume from what I've read about this work that we're reporting today that is one of the sources where these rock samples have come from, the Myrtle drill cores. Because what turns out to be the case is that the drill core samples and other rock samples as well, which are from the area, excuse me, indicate that the asteroid that wiped out the dinosaurs, the Cretaceous Tertiary impact, as it used to be called, it's called something else now, 66 million years ago, that asteroid was actually a particularly a fairly rare type of asteroid, which is called a carbonaceous chondrite. And as the name implies, these are stony asteroids, but they're rich in carbon. They're quite dark in color. And what the scientists have done, I can't remember whether I mentioned it already, but it's come from SWIRI, the Southwest Research Institute, which is, I think it's Colorado, if I remember rightly. That's where the team of scientists that have done this work are based. They do marvelous things at SWIRI. The whole of the outer solar system is their regime in terms of understanding what's going on. But this work, it's looked at whereabouts these things come from in the asteroid belt. And it turns out that when you examine, and I'm talking now about the main asteroid belt between the orbits of Mars and Jupiter, not the trans-Neptunian objects or the Jovian Trojans or anything like that. This is the main asteroid belt. The carbonaceous chondrites tend to inhabit the outer region of that asteroid belt, so they're nearer to Jupiter. And it was always thought, or it has been thought, that those objects wouldn't find it easy to whiz in towards the inner solar system. I mean, the asteroid belt is pretty stable, which is why it's there. It's all this collection of debris that maybe would have formed a planet had Jupiter not been so near. It's thought Jupiter might have, disturbed the formation of a planet between Mars and Jupiter. And what we're left with is the debris, the planet that never was, the asteroid belt. But the asteroid belt itself is divisible into many different sectors. And the outer region is where these carbonaceous chondrites tend to hang out. And so what scientists have wondered about is there a mechanism that gets them into the inner solar system where they might collide with Earth? And what they've done is they've run many simulations of the way the gravitational field of Jupiter and Saturn and other planets kind of tickles these asteroids at the far boundary of the asteroid belt and pushes them into orbits that will bring them towards the inner solar system. And sure enough, that works. They can produce a scenario where this happens, and that's allowed these scientists to do statistical analysis on that kind of phenomenon. That these asteroids are tipped out of their stable orbits on the edge of the asteroid belt and pushed into orbits that will intersect with the Earth's orbit. So they, in fact, their statistics suggest that a 10-kilometer asteroid of the kind that wiped out the dinosaurs would hit the Earth on average once every 250 million years. And that's sort of ties in with, the Chicxulub event, the crater that is the result of that dinosaur wiping out impact 66 million years ago. And more than that, they found that when they analysed these asteroids, more than half of them would have been carbonaceous chondrites, exactly what we find with the Chicxulub impactor. So really, what it does is it sort of lets you look as well. I mean, let scientists look at the other big impacts that have affected the Earth's history. The dinosaur killer is the one we all talk about because it probably opened the way for the evolution of mammals, eventually ourselves. Had it not happened, the dinosaurs might have hung around a lot longer. But there were other impacts as well in the Earth's history, and so they're looking at these too to see, how many of those were carbonaceous chondrites and whether it matches the statistics that they're forecasting.
Yeah, it does appear that these impacts by carbonaceous chondrites are more common than they originally thought. Is that a fair statement?
I think that's right, yes. And it's actually interesting because it ties in with some other research that was released this week, which I haven't got in front of me. But that's about the way planets have changed the orbits of asteroids. And it's a surprise, actually, because there are some even more carbon-containing asteroids which are extremely red in colour, and most of them are the trans-Neptunian objects, the Kuiper belt objects beyond the orbit of Neptune. But it turns out that there are a few of those in the main asteroid belt, and that's suggesting that gravitational processes have allowed these very, very red objects, really primitive objects, which are basically leftovers from the formation of the solar system. It's allowed those to come out from the depths of space, which is where they would have been formed, and inhabit the main asteroid belt between Mars and Jupiter. It's so that they can see gravitational mechanisms by which that might happen, which kind of ties in with what we've been talking about. That's completely independent research.
And it's not surprising that they used computer modelling to figure all this out, because how else can you do it? But they used NASA's supercomputer Pleiades, which I think was portrayed in the movie The Martian, to solve an orbit and retrieval system to rescue this stricken astronaut. But they looked at like 130,000 model asteroids to work out how these things get shifted out of their position. And I think the answer was some sort of thermal effect. I think was
that's right.
Thermal forces.
Yeah, exactly. So it's the way they're heated, and perhaps heating on one side rather than the other preferentially changes the orbit.
Yeah, fascinating. All right, so now we know where it came from, and we hope there are no more. But it stands to reason that these things continue to happen. We just so every 250 million years, we've still got around 180 million years to wait. We should be fine.
But remember, it's statistics, though, and it could happen tomorrow. Except the good thing is that we've got something the dinosaurs didn't have, which is telescopes all over the world, which are looking for these things. So.
And nuclear bombs and Bruce Willis.
And Bruce Willis, of course, yes, all of the above.
Going to save us all. It's good, though, that they've been able to track it down. Yeah. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Space Nuts.
Don't forget to visit our website if you want to have a look around. You can check out the Space Nuts shop. You can look at the latest news from around the astronomical world. It's all available at spacenutspodcast.com or spacenuts.io. We've managed to secure that URL, which is a little bit easier to remember. Spacenuts.io is the new URL for Space Nuts. All sorts of things to see and do there. Of course, if you browse through the Space Nuts shop, you'll find all sorts of fascinating things, from flip-flops to books to hoodies. So when you go robbing a few banks, they won't know where you're from or who you are. Of course, it will have this on it. Look,
yay!
It will have the Space Nuts logo on it, so that might sort of be a dead giveaway, but worth looking at. And if you've got someone that you need to buy a gift for and you just think, oh, my uncle's a super geek and I really don't know what to get him, Space Nuts shop. There you go. Now, Fred, we've got some questions, and our first one comes from the Netherlands.
Hey, guys. This is hi Andrew, hi Fred. This is Remy Trottier. I'm from the Netherlands, from Leiden. I used to live next to the observatory that I think Fred mentioned before. I have a question about quasars and pulsars. First off, maybe you could tell me the difference again, because that's mind-boggling to start with. Also, my burning question is, how does matter or radiation or whatever squirt out of the gravitational pull of the black hole? How is it possible that such gravitational pull, that it still can go out of it? And also, I think Fred mentioned before that they are extinct. Can you maybe explain that to me again? I would love to hear it from you guys. I love this show, and I can't wait for the bumper sticker. Thanks, guys. Keep up the good work. I love you guys. Bye-bye.
Lovely to hear from you too. Thank you. And I think they're extinct because of an asteroid. Asteroid. Maybe not. But let's start from the top of the list, because I heard paper rustling there, so I'm thinking there was quite a list of questions going on. Pulsars, quasars, what's the difference?
A lot, really. Like many things in astronomy, they've got similar names, but quite different objects or quite different things. It's a bit like dark matter and dark energy. We really should think carefully about how we name things. And I remember, Andrew, when I was just a youngster, I don't know, in my early teens, probably reading a lot of astronomy books, half of which I didn't understand. And I always got elliptic and ecliptic mixed up, which are two quite different things as well. Ecliptic's the plane of the Earth's orbit, and elliptic is the shape of an orbit, an oval. And I couldn't understand what these I thought they were all the same things. Anyway, never mind that. So the two terms, actually, pulsar and quasars, both date from the 1960s. It's a very 60s thing. And a quasar, the name comes from, it's kind of an abbreviation of quasi-stellar radio source. And there are two halves to that. Quasi-stellar means it looks like a star, so it's a point source, and the radio source means it emits radio waves. In fact, we now know that quasars don't necessarily emit radio waves. There are radio quiet ones, but that's kind of how the term originated. And it's a good term, quasi-stellar radio sources collapsed into quasars. Nowadays, they've got two slightly different meanings, but that's all right. We don't need to worry about that. So they are things that look like stars, and they shine brightly, but they emit radio waves. Many of them do. And the thing about stars is they don't emit radio waves. So for a while, people were puzzled about what they are. And then some work done by a group of American and British astronomers, the British side of this, and Australians, I should add, all thrown into the mix. Cyril Hazard was a well-known British astronomer at that time. I've met him several times, a really interesting guy with an accent not very different from mine. Excuse me. He was one of the people who worked out, first of all, that these things were extremely small. In other words, the source of light was tiny. It wasn't a big galaxy or anything, but also that they were a long way away, and that they're what we call extragalactic distances. In fact, very remote indeed. Their distances are almost all, measured in billions of light years. So that's quasars. Pulsars, famously discovered by Dame Jocelyn Bell Burnell, who I'm delighted to say I also know. She wrote a lovely endorsement for Exploding Stars and Invisible Planets, which I was thrilled with. I used to work alongside her in Edinburgh. So Jocelyn found these spikes of radio radiation, and it's well known, the story. She wrote LGM next to it on the output trace, because this stuff came out on paper traces. LGM meant little green men with a question mark after it, because it was, a kind of wow signal. But very quickly it was realized that these weren't. Her PhD supervisor got a Nobel Prize for that work. Jocelyn has always been extremely gracious about that, and says it would have been inappropriate for her to be on the Nobel list, even though a lot of people say, yeah, it's typical. The young woman student does all the work, and the supervisor guy, a middle-aged white guy, goes off and takes the Nobel Prize. And that's certainly a valid point. But as I said, Jocelyn herself has always been gracious. So what are they? They're neutron stars. So these are tiny objects. They're 10 kilometers across, which are beaming radiation from their magnetic poles. And if they're on their side, which they often are, they flash this stuff through the universe like a lighthouse beam, and we see them as pulses of radiation. So that's the difference. Quasars are at very great distances. Pulsars tend to be in our own galaxy, although there are extragalactic ones as well. One's a defunct star. That's the pulsar. It's a neutron star, a star that's collapsed at the end of its life, whereas a quasar comes from a supermassive black hole. As we now know, they didn't know that in the 60s, but it's a galaxy with a supermassive black hole at its center, which is absolutely voraciously consuming the stuff around it. So it's in an environment that is rich in gas and dust. It's chewing all that stuff up and basically beaming out the radiation. Now, that is one reason why they're extinct today, just to cut to the end of the question, because we don't see in today's universe, and by that I mean we're looking back only a billion years or so. So looking out into space to a billion light years means you're looking back a billion years in time. We don't see. I think there's one candidate which might be nearer than a billion years, but all the rest are more than. In fact, I think the next nearest one is 2.5 billion light years away. So 2.5 billion years ago, as we see it. And so the thinking is that we don't see these in today's universe because there isn't the raw material around them for the black holes to chew up and spit out. So now the middle bit of the question is the bit that I always find it hard to get my head around as well, and that is how do supermassive black holes like the ones in quasars, how do they make material avoid being sucked into the black hole and squirted out in the north and south pole of the black hole at relativistic velocities, nearly the speed of light?
We actually talked about last week, but yeah, it's a good question.
We do talk about it quite a bit, yeah. And it's all about magnetic fields. First of all, the thing to remember is that this stuff does not get within the event horizon. Once material gets inside the event horizon, it's gone. There's nothing will save it. But this is stuff that's whirling around the black hole event horizon at very high speed. And it encounters these incredibly strong magnetic fields. And the tendency there is for them to be, for the material to be focused along, or collimated is the technical term, in parallel beams along the poles of the black hole, the rotation poles. So really quite remarkable physics there. I confess I've never looked at the equations. They'd probably scare me to death. So I've kept away from that. But it does work, and the theorists are very, very confident that this is what happens. It's stuff that nearly gets sucked into the black hole, but not quite. We know that at those distances from the black hole event horizon, even light is bent round in a circle. So it's remarkable stuff.
Indeed.
Thank you for the question.
All right.
Great question.
Yes. Lovely to hear from you, and I hope you're well. Let's move on to our next question. This is a text question, and it comes from Beverly in Texas. I like this question because it's not something we've really focused on before. I've been reading about the Voyager spacecraft. I read that Voyager 1 crossed the heliopause in 2012 and Voyager 2 is still in the heliosheath. I haven't heard a lot about the heliosphere, so I'd appreciate any information you could give regarding it. Also, what might the Voyager spacecraft 1 and 2 tell us once they've passed into interstellar space? Will we continue to communicate with them? I really enjoy your podcast. Thank you, Beverly. Well, thank you, Beverly. Great question. Where do you want to start with that, Fred? That's a ripper.
It is. It's great. And so the heliosphere is basically it's just the region of space that is where the sun's magnetic influence prevails or predominates. So we've got a similar thing on Earth. We call it the magnetosphere. It's the Earth's magnetic field and the area in space where the Earth's magnetic field it dominates. Likewise, there is a magnetopause, which is the boundary between the Earth's magnetic field and where the sun's magnetic field predominates, because that's the sun's magnetic field pervades the solar system. Yep. So there's the same thing at these great distances, and we're talking now at 20 trillion kilometers. No, we're not. We're talking 20 billion kilometers. 20 trillion kilometers is halfway to the nearest star, and we're not there yet. Sorry. Sorry about that. 20 billion kilometers of distance from the sun to more or less the two Voyager spacecraft. Voyager 1 is further away. It's a bit further. And so what you've got with the sun's magnetic field, we're in the heliosphere. The heliosheath is I'm not clear, I'm not an expert on these magnetic fields. I've got colleagues who are, but they're not here, what the difference between the heliosheath and the heliopause is. But it's basically both of them represent the boundary. I think there are differences between them, the sun's magnetic field. I guess the sheath is, in a sense, a boundary region of magnetism where the magnetic field changes quite dramatically, and the heliopause is the edge of it. But when you get outside the heliopause, what you're feeling is the magnetic field of interstellar space. It's basically the magnetic field of the galaxy. And so that has a different magnetic signature from the heliosphere, the heliosheath, and the heliopause, whose magnetic signatures have been recorded by Voyager. And in particular, Voyager 1, exactly as Beverly says, crossed this boundary some years ago. Now, Voyager 2 is going in a different direction. It's actually going in the southern hemisphere. In fact, you remember that only the Tidbinbilla dish can actually communicate with Voyager 2. So Voyager 2 is in an area where I think the heliosphere is not perfectly symmetric. It's got bumps and dints in it, caused by the fact that it's a dynamic thing. It's all about magnetism, which changes. And I think there were reports that Voyager 2 had crossed the heliopause and then that it hadn't, because maybe the boundary changed or something of that sort. But I think it still is within the sun's magnetic field of influence. Okay. Voyager 1 isn't, though, definitely out of it. And just to answer the final bit of Beverly's question, how long will we be getting readings from these spacecraft? So what's been happening, their power supply is dwindling. They've both got these RTGs, radioisotope thermoelectric generators, to provide the power, which is plutonium, hot plutonium, which is very slowly cooling. And what's been happening is that mission controllers, I think both of them are still in contact with Earth. I'm pretty sure of that. Mission controllers have been steadily switching off different instruments just to reduce the load on the RTG. And I think, the magnetometers and the transmitters are among the last which will be turned off. But I think we might still be hearing from them until the mid-2030s, as I understand it.
I do remember seeing, I think it was in a documentary series about when Voyager crossed that threshold, they detected that it happened due to some strange radio signal that they received from Voyager 1. I don't know exactly how that transpired, but they picked up this weirdness in a signal. And,
maybe, yes, that's right, in the signal itself.
And they put it down to this crossing the threshold from into interstellar space. And I suppose that's one of the other things that Beverly wanted to know is what can the probes tell us once they're traveling into interstellar space? Will there be anything to learn from them?
Yeah, indeed. And certainly the main thing is the magnetism. Now, the solar system its gravitational influence goes on a long way beyond that, because you and I have spoken before about the Oort cloud, the comet reservoir, which is somewhere in the region of 10% of the way to the nearest star, a spherical region. Now, it is possible that one day Voyager 1 or Voyager 2 might run into one of these things, but it's so far away that that's going to be quite a number of years. I can't remember how many years yet. And I think by then they will have lost their power supply, and so we won't be hearing from them anymore. But in the meantime, they will be able to tell us about the external magnetic field, about the magnetic field of the galaxy, how it changes, how it fluctuates, direction, things of that sort. One final footnote to this, if I may, and it's a plug for the new book, of course, my new kids' book, Space Warp, that you might remember it's full of cartoons that I've drawn. The last one, the very last one, is a portrait of Voyager, which is thinking to itself, it's getting a bit lonely out here.
Yes.
Voyager 1, yeah.
I imagine it would, because these are objects that have travelled farther than any other thing made by humanity.
Yes, they will do, and they probably outlast us, Andrew. They probably outlast the species.
Unless they hit something in the Oort cloud.
Yeah, that's right.
Fascinating stuff. And Beverly, thank you so much for your question. Lovely to hear from you, and hope all is well in Texas. And that brings us to the end of another program. Fred, lovely to talk to you. Of course, by the way, anybody who has questions, please go to our website. Make sure you click on the AMA tab, and all the information you need there on how to record a question or send us an email question is there. So the AMA tab on the spacenutspodcast.com website or spacenuts.io, it'll take you to the same place. So you can ask your questions of Fred through our website. Yes, we're at the end of another episode. Fred, thank you so much. Always good to talk.
Always a pleasure talking to you too, Andrew, and learning new things about the universe. Indeed
we are. Professor Fred Watson, astronomer at large, part of the team here at Space Nuts, and we thank him as always. He'll be back next week. Thanks to Hugh in the studio for pushing all the buttons and changing the toilet paper. And from me, Andrew Dunkley, thanks again for listening and watching, and we'll catch you on the very next episode. Bye-bye.
Space Nuts.
You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.